Okay, girls, to conclude the first part of our Corona video series, we're looking at exercises 6 through 7, where we are going to consider some linear equations. Now, one thing that we've talked about in terms of recognizing something as linear is that it has a constant rate of change, and it also creates a line when graphed. Remember that a line in algebra is a singular straight line. So what we haven't talked about is how to recognize it from a rule, but the word linear is not foreign to you and certainly was used extensively in this course before we got to this unit. Think about polynomials. How do you classify a polynomial as linear? It's first degree. Now we've been writing everything so far as a y equals some stuff in terms of x. Notice that this is a linear polynomial in two different variables. Remember, to find the degree of a polynomial, you consider all of the monomials involved, and you find what is the highest number degree. Now, the highest number degree here is 1. This is a first degree polynomial, making it a linear polynomial, making it a line because it has two variables, aka two dimensions. So, we're looking at the function y equals 2x plus 4, and I want to do a couple things with it. For one, I want to graph it. First off, boy, how many points do you need to make a line? Well, if I was just over here daydreaming about the XY axis and I wanted to draw a line, say it goes through there and it goes through there, I have enough information to draw my line. So I really only need 2 points that this line goes through and I'm good to go. I want to pick the easiest points possible. So what would be some real easy input values to find output values that go with them? Always good to know what is happening when x equals 0. Remember, that was kind of an important point. We said that's the output value when the input is 0. So if I put 0 into this, the savvy girl is thinking to herself, Mr. Wells, you've already taught us what that is. It's supposed to give me that number, which it does. So that tells me from those two pieces of information, the line goes through 0, 4. Now I need another point though, so I don't know, what's another easy number to work with? Let's let x equal 1. Okay, so we'll say y equals 2 times 1 plus 4. A little bit more work, but not all that much. When the input is 1, the output is 6. So I now have 2 ordered pairs that this line goes through. Now don't get lazy here. This is already lazy enough. I need to get up to 6 on the y-axis and up to 4 on the x-axis. So I know it goes through 0, I'm sorry, I don't need to get all the way to 4 on the x-axis. It needs to go through 0, 4, so 0 on the x, 4 on the y. And it needs to get up to 1 on the x-axis, 6 on the y-axis. So up to here. Now here's where you don't want to get lazy and just say, done. This line is infinite and will continue on forever and ever until the end of time, and probably further. So if I'm given a plane to graph within, I always want to draw my graph from edge to edge, unless I have reason otherwise, which I'll find out about in the next video. So let's graph the next equation. Exercise 7 says y equals 1/3 x minus 1. Now we already noticed from the last one, this number comes from when the input is 0. We found when we let x equal 0, we got the number that's already in the equation. That is exclusive to when I have something in this precise form, which you'll learn more about in the short future. But I can make a pretty good conjecture that this line is going to go through the point 0, -1. But I need another point, and I know you guys love fractions and everything, but let's try to be savvy about what x value to pick so that we get an integer value for the output. Because imagine if I put in 1, I'm going to have 1/3 minus 1, and that's not going to be an integer. So it might not be the easiest thing to graph, and it might give you a headache otherwise. So let's pick a number for x that will give me an integer value for y. What type of number would do that? Of course, any multiple of 3 will do that, because then I'll be able to cross cancel out the 3. So let's be simple about it and just say let x equal 3. So now we have y equals 1/3 of 3, which is 1, minus 1. So 1/3 of 3 cross canceled equals 1 minus 1, everybody's best friend, 0. So I know it goes through the point from here and here, 3, 0. So, kind of a wobbly x-axis, but good enough for YouTube. 0, -1, and 3, 0. So, there'll be a number of things that I want you to start noticing about equations and what they end up looking like. Here I want you to compare the equation 2x plus 4 to the equation 1/3 x minus 1. There's a couple things that I want us to think about here. For one thing, I noticed that this point is above the x-axis due to it being positive. This point is below the x-axis due to that being negative. Also, I want you to notice that this one seems to be a bit steeper than that one. This one is steeper than that one. And remember, that's coming from this number, which is the rate of change. This number, meaning that if we're thinking about delta y over delta x being 2 over 1, every time that x increases by 1, y increases by 2. But here, every time that x increases by 3, y only increases by 1. So the rate of change is slower here than it is here. And again, we're going to talk much more about that, and nobody should be saying the S word right now. Okay, exercise 8. Y equals -4/7 x plus 4. So I think I'd like you to, if you would, pause the video here and try to make a graph of this yourself. And again, you know you get 1 point for free. You know what the output is when the input is 0. It's looking right at you. I want you to pick the second point advantageously so that you get an integer value for y. So pause the video and sketch a quick graph. Okay, so like I said, we know that this is what we get when we input 0, because you can imagine plugging in 0, this goes away, y equals 4. So I know that I get the point 0, 4 for free, only when I'm looking at this exact form, y equals something. But now I need to pick something for the other point. The savvy girl would have said, I'm going to choose some multiple of 7, because that will allow me to cross cancel this. So let's let x equal 7. It's a bad 7. My apologies to everyone and their families. Let x equal 7. So we're going to plug that in. And we're going to look and we're going to see these cross cancel. So I have y equals -4 times 1, -4 plus 4. Oh, neat. We got y equals 0 again. If you remember, we got that on exercise 7. So we know that we have the ordered pair 0, 7. Now, I've got these two ordered pairs. These are the points I'll plot, draw a line through. Notice how the rate of change is different in this example than it was the first two. The first two rates of change were positive. This one's negative. So this means one of two things. Either as x is getting larger, y is getting smaller. Or as x is getting smaller, y is getting larger. You have a negative rational number here. And you can think of that number being one of two things. Remember, fractions are just division problems. A negative divided by a positive is negative. A positive divided by a negative is negative. So you can think about this fraction in one of two ways. You're just thinking about As one gets bigger, the other one gets smaller. And that's going to correlate to which direction you're moving on the graph. So I need to get to 0, 4, and wrote that backwards. Grace was cringing the whole time. 1, 2, 3, 4, 5, 6, 7. Okay, so I've got a point here. I've got a point here. And notice what that negative rate of change is doing. This graph is moving downward. This graph is decreasing. If you remember, we talked about how graphs are either increasing, decreasing, or are constant, perfectly horizontal with no change happening. Okay, so there's number 8. Number 9. Gosh, I'm so close to the last video and I've only been recording for 15.5 hours. Y equals negative 8x minus 4. Okay, so pause it, graph it yourself, and we're back. So we've got the point right here. When the input is 0, I know the output is 4. Now let's pick another point. Now I don't have a fraction like I did on the last two. I can pick whatever I want. Let's let x equal 1. Or negative 1 if you feel like getting a positive, since this is also a negative rate of change. But I'm going to say let x equal 1. So that's going to give me y equals negative 8 times 1 minus 4. I suddenly regret everything and wish I would have done the negative one. Y equals negative 8 minus 4, so y equals negative 12. So this gives me the ordered pair, 1, comma negative 12. So you can see, even if I were to make a small table here of 0, comma negative 4, and 1, comma negative 12, as x increases, y decreases. That's where the negative rate of change is coming from. As x goes up by 1, y is going down by 8. So I know that I could also find another point if I wanted to increase x by, I don't know, 2? If x is getting bigger by 1, y is getting smaller by 8. So if x is getting bigger by 2, y is getting smaller by negative 16. So that'll give me a negative 28 here. So I know I've got another ordered pair. The rate of change will take me from one point to another point as much as I want to go. Okay, so try to graph this with my arm angled so I don't bump the tripod. Okay, we need to get to negative 12 on the y-axis. Perfect. And negative 4 on the x-axis. Okay, so let's compare these two graphs. This graph doesn't appear to be as steep as this graph. I would much rather sled down this hill than that hill, much faster. So looking at the rate of change here, both are negative, both are decreasing. Before we noticed that the larger number seemed to be the steeper line. Here I see the smaller number. Negative 8 is smaller than negative 4/7. So we might want to be thinking more about absolute values here than about the actual size of a number. The absolute value of negative 8 is larger than the absolute value of negative 4/7. So the larger the absolute value of the rate of change, the steeper the line will be, whether it be positive or negative. Okay, that's all for now. Video 2 coming up shortly. You have a 10th exercise to do on your own involving Desmos. So enjoy the enjoyment, girls.